Hello growers, Jeff with TotalGrow Lights here with an overview of our lighting calculator tool. This calculator is based on more than a decade of walking alongside growers to sculpt light plans around their unique situations, goals, and challenges. We put it together to equip you to get a feel for what an appropriate lighting approach is for your unique combination of facility type, crop, location, layout, and business goals, and to compare the effects of different options. Ultimately, there's no substitute for working through these details with an expert from our team to further analyze your opportunities and challenges, especially when we factor in things like utility incentives or power limitations, which could significantly impact the best fit. But this tool will quickly get you most of the way there in most cases. So there's three overall sections to the tool. And first up, we start with the inputs you'll need to provide. First, we select the environment. If you choose greenhouse, the natural light is factored into the plan. And for indoor or vertical setups, we assume no natural light. Next, your selection of crop will determine how much light we try to provide. Of the options, propagation/young plants targets the least amount of light. Cannabis flowering is the largest amount of light, and the others are various targets in between. The crop isn't the only thing that influences how much light to target. If you choose optimum for lighting target, the tool aims to provide enough light to push the plants near their maximum growth rates and quality. If you choose minimum, it will target enough to keep acceptable, good enough sorts of growth with less light to reduce costs. And if unsure, you can choose balanced, but you may want to run the calculator multiple times to see the impact. The suggested total DLI is an approximate total amount of light needed by the plants based on the crop and the lighting target. DLI stands for daily light integral, and it's the total amount of light energy accumulated at a surface over a day. It's the single most important lighting metric to predict growth. If you want to target a different DLI, there is an override option. If you're growing in a greenhouse, the state and the darkest active month fields allow the calculator to estimate how much natural light we can count on. If you grow in December, you'll need more supplemental lighting than if you don't start using your greenhouse until later in the winter or spring. And for indoor grows, these fields don't influence the recommendations. The ambient DLI in a greenhouse shows the amount of light we're counting on the sun to get to the plants based on the environment, the state, and the darkest month of use. This allows the subtraction of the ambient DLI from the total DLI target up in the fourth field to give us our DLI target from the LEDs. And again, you can override this if you'd like to choose a different number. Next, we need the maximum hours per day that you'll run the lights. For most crops, 18 hours is appropriate. For short day photoperiodic effects, like cannabis flowering, this will usually need to be about 12 hours. And some plants in growth stages can use up to 24 hours. The more hours per day we can run the lights, the less intense the lights need to be to still add up to that target DLI. And the next calculation is the PFD target. So PFD is the photon flux density. It's the amount of light hitting a surface every second, essentially the brightness. And it's calculated from the DLI target and the hours of runtime. This number drives the light plan. The higher the PFD target, the more lighting power per square foot needed. And again, you can override that target if you'd like to. The next five fields are the physical growing layout to be lit. Enter only the dimensions that actually need lighting, not your entire room or your bay. So this might be the dimensions of a shelf or a bench, a room, a bay, or a portion of a room or a bay that has continuous plants before getting to an aisle. If aisles are small, such as maybe 2 feet or less, you can typically ignore them and just enter the dimensions of the overall space. So we'll put some placeholder numbers here to get something to work with later. The quantity of grow areas is the number of shelves, benches, rooms, bays, or other grow areas as described above. And the max height from the plants to the lights, this determines which particular lights can be used without creating uniformity problems. The more available height, the farther apart lights can be spaced, allowing us to use a lower quantity of higher powered lights, which will typically cost less and be simpler to implement. If there's not much height, we'll use a higher quantity of lower powered lights to spread out the light and maintain uniformity. TotalGrow has a wide array of light fixture options to ensure that there's always a good fitting solution. Finally, the efficiency versus initial cost priority. This guides whether we err on the side of a more expensive, higher efficiency light model, which will cost more initially but reduce your power bill, or whether we go the opposite direction and try to minimize initial costs with a more budget friendly light that has good but not quite as excellent of efficiency, or aim for a middle balance. The yellow energy and cost portion of the calculator will help you compare different inputs and decide what actually fits your situation and goals best. But in general, if you're using the lights for 3 months of the year or maybe less, you should target the minimum initial costs because the payback from higher efficiency will be slow. If you're using lights more like 12 months of the year, it's probably going to be worth investing in higher efficiency options. Utility incentives, power costs, available power, and other factors like that can also have an important impact on this decision whether you should go more maximum efficiency, minimum cost, or something in the middle. At this point, your work is basically done. Hit Calculate Light Plan and look at the Light Plan Suggestions area. So first, we pick the light to be used based primarily on the PFD target and the maximum height. You can switch to other options if desired, and you'll see the fields below adjust accordingly. This is moving up to the higher efficiency versions of the same power light, and you can see the photon flux output per light goes up. But if you get to the point of quoting these, you'll see the cost also goes up per light. So based on that photon flux output per light and the size of the grow areas entered previously, this next field estimates how many lights total would be needed to provide enough light to hit the targets before we consider actually the growing space dimensions. And that's where the next 6 fields come in. This is where we turn that estimated total number of lights into a real lighting proposal, essentially. How many of rows of lights are needed and how many lights per row to get close to or hit that target amount of lights with a configuration that spreads the lights relatively evenly across the space for good uniformity and uses whole quantities of lights and doesn't result in trying to use a quarter of a light fixture. The target height does not have to be hit exactly when you actually go to install the lights, but this gives something to aim for. In most cases, the light heights above the plants will be about 50 to 100% of the light spacing, typically somewhere around 60%. So for example, if the lights are on 12-foot centers, the lights could be between 6 and 12 feet from the top of the plant to the bottom of the light, but around 7 or 8 feet is more ideal. Finally, the approximate PFD field indicates the average expected photon flux density that the setup from those 6 prior fields actually would create. And this includes some estimates of losses to typical amounts of spillage outside of the grow area and dust and debris, making the light output over the course of time be slightly lower than what it was initially. But we can compare this number to the target PFD number when we're just using raw calculations to see that's pretty close. Next, we move over to the energy and cost calculator part of the tool, which can help you with some of your decision-making process. And you have the option of keeping this box checked for a relatively simple and quick estimate of things or unchecked so you can really refine all of the inputs that are being used for that ROI calculation. And to be able to do this return on investment calculator, we need something to compare against, a legacy light. So when we're comparing against high-powered lights, it's typically a high-pressure sodium. Whether that's the older single-ended style or the double-ended style will affect how much light and how much efficiency we're comparing against. And the less efficient light, the more appealing the ROI is going to be. The top few lines here, if they all look relatively accurate based on what you would expect, and the particular lights you're using, the age of the lights, then we can move forward right down to the months per year of usage. And this will have a strong impact, as mentioned before. Shorter months, less months used per year is going to be a slower ROI in favor of the less efficient lights that cost less initially to be the best fit. Whereas If you're using them more like 12 months of the year, then you're going to end up probably using the higher efficiency. But we'll just stick a number right in the middle with 6 right now. And now you've got estimates of your annual kilowatt hours of usage. These electricity cost numbers, these are based on the state that was put in before. This is 2023 data for just average commercial electricity costs. So it should be at least somewhere close, but you can uncheck that box and refine it if you would like to. Now we've got annual power costs here, and that gives us the basis of our ROI calculation. And then to add in the actual investments up front, we need some sort of an estimate of the cost per light. And that should include the accessories that are on each light, like power cords. And then other upfront costs, these would be electrician bills, electrical infrastructure, or discounts like utility incentives, which again, we can help you out with. And so if we figure this has some utility incentives to help out on the costs, that'll reduce the total upfront costs and make the ROI even more appealing. So if this was the reality that you were working with, it would be an extremely appealing choice over the 1,000 watt high pressure sodium lights in this case. But obviously, all of the different inputs will have a pretty big impact on this. Now, finally, there's one more part of the website here, and this is perhaps most important. The bottom form will provide us with the last information needed for us to connect with you and turn the estimates and suggestions above into a refined and optimized plan of action. No automated tool can capture all factors involved. You may have other equipment to plan around, incentives to be explored, a limited amount of power available, existing structures to try to hang from, like the trusses every 12 feet that might be in a greenhouse, or any number of unique needs, questions, and opportunities. So use this bottom submission form to send the information you've compiled to us and allow us to provide the next level of feedback, pricing, or whatever else might be helpful. Take advantage of our 11 plus years of experience in this industry for free guidance. We love to help.